We have a simple equation here with three terms I want to start with. Everybody draw a dashed line through the equal sign to separate the sides of the equation. That is your threshold, okay? The moment that a term crosses over that threshold, it changes signs. So I've got some terms here, like I told you yesterday that terms are like playing cards, right? So if I chose a playing card, like negative 2x, and this term is living on this side of the threshold, the moment it crosses that line, it switches to a different sign, okay? It is, two-sided card. But that idea is super important. The challenge that you have to do in Mega High, the Jabara game, does this very well. It has tiles, right? You can combine, you can slam tiles together to get a new term, or you can take that tile, you can ship it to the other side of the equation, and it changes the sign. That's exactly what I want to do here, okay? So the whole basis of this lesson is how do you move terms from side to side? You add them or subtract them based on what their current sign is. So everybody put a box around the negative 2x. One of the mistakes we can make is not identifying that term, first of all, as negative, okay? I did that from the beginning, right? I said, hey, look, there's a negative 2x. And some people will argue with me and say, no, that's a minus 2x. I'm like, I don't care. If you put a box around it and go lift off the page and you look at it, wouldn't you say negative 2x? Right? That looks like a negative to me. So we're never going to argue about whether it's negative or a minus sign. Negative is or minus is negative value. Okay? We move it over here. So I actually wanted you to take that, like with a little arrow, and say, you go over here. And the moment you cross the threshold, it's now a positive 2x. Okay? But you don't have the ability to like move it on the page. So what you should do is you should cross it out right here, shouldn't you? Because it has literally moved sides of the equation. So cross out the negative 2x. It's no longer over there. What is still over there? 7. Okay, so we have 7 equals. Please put the equal sign on the threshold, okay? Because it's always going to live right there, so it separates the two sides. And then here we have like terms. You're going to take those two tiles and you're just going to cram them together, add the coefficients, 6 and 2, you get 8x. Something I should be saying every day. If I don't say it in a given day, yell at me. What is the glue that holds a term together? Multiplication. So if you get to this moment and you're like, you know what, I only have 2 terms and one of them's held together with glue, you need to rip apart the glue. So the opposite of multiplication, of course, is division. You guys know this stuff, okay? It's not like I have to reteach this, but there's a reason for why we do it this way. The inverse of multiplication is division. You want to divide the 8 on both sides of the equation, okay? Of course, the threshold separates the sides. And then when you divide by 8, you get 7 over 8. I have a feeling that if you got this answer, let's say on an assessment in the future, you would feel a little iffy about it because it's a fraction. And most times that happens with students. They're like, I got a fraction, is that okay? I'm like, well, did you do your steps correctly? I think so. Did you plug it back in to check? No. Well, that's your next step, right? Would be to take that 7/8, put it back into the original form of the equation and say, is there balance in your equation? If the answer is yes, then it's going to work, okay? I'm actually going to forgo this step right now because I know it works, and our steps are sound, okay? But just don't freak out. All right, here's a Mr. Strickler class on what not to do, okay? Phase 2 of the lesson. Any term, fill in term right there, can be added or subtracted to both sides of the equation. Any term can go from here to here and flip sign, right? Unless there's these 2 conditions are met, okay? This is what not to do. As long as it is not in a group, write that down. That's the first part. A matches example A down here. I want you to look at the group that's given in example A. See that 3x minus 10? They are grouped together with grouping symbols. Let me find my 3x card. Hold on.
Never mind.
Is this your card? Okay, there's a 3x right here. Oh, draw the threshold. So dash line through the equal sign. And Mr. Strickler said you should take terms and move it to the other side and combine. You're like, oh, there's a 3x right there. Let's take the 3x and move it over here and combine. You can't do that, okay? You can't. I remember the cheer at the basketball games. They're like, you can't do that. Yeah, you can't do that because there's a group And before you do that, you have to break apart the group. So you'd either have to do, number one, distribute this 2c to 2, you have to distribute, or divide by the 2, because the opposite of distribution is division, like multiplication division. But that 2 is your problem, okay? So here's what I actually want you to start doing that step like this. minus 3x to both sides. And then circle it and do like a Ghostbuster symbol through it. Or like, do not enter. Do not do that, okay? Take care of the group first. Get the group to be blown apart. And then you don't have a group anymore. And then you can move terms freely about the cabinet, okay? 3x can become negative 3x and so on. That's condition number 1. You can't do that. Number 2, if it's a part of a fraction. So any term can be added or subtracted from both sides of the equation as long as it is not in a fraction. Example B. There's a 2y right there, there's a minus 4. Let me look at the minus 4. Okay? See if I can find the minus 4. The minus 5. 6. There you go. It's so tempting. You see the minus 4, and he's like, I would really like to add that 4 to the other side because I want to combine it with the 12 to get 16. So you're like, minus 4, add over here.
Don't work.
You can't do it because it's a part of a fraction. Just like you'd have to blow apart the group, you have to get the fraction out of fraction form before you can do anything with the 2y or the negative 4. So you can start to do it. You would add 4 to both sides like this. And then you go, please don't do that, okay? Before you do any of that, you would have to multiply both sides by 5, okay? In the Kahoot today, I don't know if anybody solved this equation right here.
Yes.
I did.
There was a minus 4. This is the exact idea. You can't subtract 10 until you've taken care of the negative 4. You had this one, didn't you? Yeah. You multiply both sides by negative 4, then you can subtract 10, and then move terms around, okay? All right, it says remember this. Well, I think I got out of order in my lesson, so you probably don't remember this. So let's talk about it for the first time.
No.
Draw your threshold. But on the left side of the equal sign, I want you to go into pretend world and imagine that that is a slope and a y-intercept. You see it?
Yeah.
What would the slope be?
Negative 8 over 1.
Negative 8 over 1. And the y-intercept would be?
6.
6. Label those two parts. The slope is negative 8 over 1. And the y-intercept would be 6. Okay. I know that's not what we have right here, but I'm just going to pretend like that is the case. Over here, I want to do the same pretend mode, okay? Wouldn't that be the slope of negative 8 over 1?
No.
And the y-intercept would be 7. Label those two parts.
Yep.
Y-intercept. Question. Will those two lines, with those slopes and y-intercepts, will they cross?
No. No.
No, they won't.
Be
Because
parallel.
they're parallel. Slopes that are the same with different y-intercepts are parallel, therefore they do not touch. So here's my argument. If I see this in an equation, okay, if I see this, I'm not going to solve this equation. I'm just going to write no solution. Okay? But wouldn't you have to inspect the equation and like actually see that that's true? Here's how you could do it. Now, let's say you don't notice that. You're not observant about the equation. You just start solving. You see a negative 8x, you're like, I'm just going to start doing this. So take this equation, write it down real big over here. Oh, forgot the next thing. 7, okay? You take the negative 8x, you move it to the other side of the equation. Here's a term. You're like, ooh, there's a like term over there. Let's move it over. The moment you cross the threshold, what happens? It's now a positive. It flips. So you move the card from this side, and it flips signs over there. It's no longer there. There's only a 6. What's negative 8x plus 8x?
0.
0.
0. Okay, those terms cancel, and you're left with 7.
6 does not equal 7.
Last time I checked, that's right, Jack. 6 does not equal 7. So you can stare at that for a while and be like, what do I do now? Or you can be like, that's not true. So you slash the equal sign, you say, not equal, bad. Therefore, no solution. Because 6 does not equal 7. That's what a no solution looks like in terms of an equation. Visually, okay, you would have had two lines that are both going down 8/1 that start in different places. And you would see this visually. You'd see a parallel line, no touch. Okay? And then algebraically, you end up in a spot where this just ain't true. 6 does not equal 7. So, sorry, no solution. You cannot solve that. There is no number you can plug in for x to make that true. It's just not possible. Okay, next. Draw your threshold. And this is a very classic setup for an equation. I want to pretend again that these are two lines, okay? So the 9 is your slope. The -3 is your y-intercept. Bailey, you're pretending right now? I'm picturing the line, starts at -3, goes up 9/1. Okay. Over here, the slope is 5, the y-intercept is -7. Will those lines cross?
No.
Will those lines cross? Yes.
No. No. No.
Okay.
No.
Luke, stand up. Here. Hold that. Exactly like that. That's a slope of 5, let's say, okay? Now, if I take another line, a slope of, if it was 5, they'd be parallel. If I make it a slope of 9, which would be steeper, will these lines cross?
Yes.
Yes.
Cross up there. Now, what if I move this over here? This is parallel. I go behind you, and I make it a slope of 9. Will they cross?
No.
Yes.
Oh, they're crossed
Back here, yeah, okay. Thank you for that.
Wow. Wouldn't know.
So, hey, if there are different slopes, okay, parallel, same slope. If I just adjust this by a slope of 1, so 5 becomes 6, they will cross. And you can see that they're converging back here. So yes, there's a solution to this. You inspect the equation, you notice there's a solution. So you're like, you know what? This is worth solving because I know I'm going to get to a number that x is going to equal. Which term would you like to move? That's totally your choice.
9 and 3.
You can move the 9. You can move the 3. You could move the 7. You can move the 5. Here's my choice. I always strive to keep the variable positive because I'm a positive person. No, because I think that's easier to deal with. So if I took the 5 and took it away from 9, that would be positive 4.
4.
That's a good choice, okay? So everybody take and subtract the 5x. Or you can do a playing card approach where you say, this is a card. Once I cross the threshold, it's now negative. I combine like terms right there. That's 4x minus 3 equals -7. Okay. Now that, friends, is a two-step equation, okay? You can go into two-step autopilot, like, oh yeah, I got this. Add 3, divide by 4. Mentally, you might be able to get through it. If not, then just show the work. It's not going to hurt you. Add the 3. This is the more acceptable way to do this, is to show both sides being added by 3 to stay balanced in your equation instead of taking a playing card approach. Cancel the 3 from one side. 4x equals -4. And then rip apart the glue, right? You got 4 times x. Divide.
5 over x equals -1.
X equals -1. Now, I don't know if like that visual right there where I had Luke come up and hold that line, I don't know if that was like compelling to you, if that made sense. Another visual I can show you is just very simply in Desmos. Check this out. This is how it would start. There's your 9x minus 3, isn't that, that's the right side of the equation.
Yes.
There's your -7 plus 5x, that's the left side. Those are 2 lines. And those 2 lines would cross back here. Look at the x part of that coordinate. What is it?
-1.
What was your solution? -1, okay. They do cross at -1. Now, what about the -12? Why is there a -12 even there?
That's the way it goes to.
That's like the height that they cross at, isn't it? If you're solving an equation and there's only one variable, like x, you would just totally ignore the 12, because you're like, well, I only care about that because that's the only thing I was given in the equation. If there was
Whoa.
If there was a y also in your equation, so let's say you had y equals 9x minus 3 and y equals -7 plus 5x. If there's an x and a y, then you have to give the x and the y, right? But if there's only an x, this part didn't exist right here. This was not given. Oh wait, check it out. If two things are equal to the same thing, then they're equal to each other. That's transitive property. Here it is again. This is why these are equal to each other. This is why this works, because if you break these apart and put them in line form, you get a coordinate. Okay? You either accept the x or both, depending on what you start with. That's where we're going. All right, cool.